Hello everyone, myself Harpreet Singh. I am a student of Plus 2B Science Group from Amrit Indo-Canadian Academy. Today in this module we will discuss about the methods of preparation of haloalkane using alcohols. Now let us see what are alcohols. Alcohol is an homologous series in which the compound containing a functional group called the hydroxyl group, that is OH. The general molecular formula for the alcohol is CnH2n plus 1 OH. Alcohols are all derivatives of hydrocarbons in which one or more of the hydrocarbon in the atom of the have been replaced by the hydroxyl group. The hydroxyl group is also responsible for imparting certain chemical or physical properties to the compound. The examples are methanol, ethanol, propanol and butanol, these containing different numbers of carbon and OH group in them. In the preparation of haloalkanes from the alcohols, there are three different ways using different reagents such as by the action of halogen acid, by the action of phosphorus halides, and the third and the last one is by the action of thionyl chloride. Let's discuss about the first method, that is by the action of halogen acid. As you can see in the first example, when alcohol group react with the hydrogen bromide, the bromine substitute the hydrogen atom leaving behind the water molecule and thus the formation of bromoalkane. Similarly, in the second and third, there is a formation of chloroalkane plus iodoalkane. Includes a process that is called Grove's process. In the Grove process, an ethyl alcohol reacts with HCl in the presence of zinc chloride to form ethyl chloride. Now you can see the example of Grove's process. First is the ethanol when reacts with HCl in the presence of anhydrous zinc chloride and heat, it will form chloroethane plus water molecule. Similarly, in the second case, propanol reacts with HCl under the presence of zinc chloride form 2-chloropropane. Now this is the time to discuss about the very unique property of this method, that is carbocation. Let's discuss. In the process of carbocation, let us take the example of neopentyl alcohol. In the first step, when neopentyl alcohol reacts with an HCl halogen acid, the H positive ion attracts the lone pair present on the oxygen in the alcohol attracts, and then in the second it will form protonated alcohol, and after the removal of water in the third step, there is a formation of primary carbocation. It is a primary carbocation because the methyl group is present to the first carbon. Now, many of us will now think that the Cl negative remaining part of halogen will attach with this primary carbocation, but it is not happen actually, because primary carbocation is very less stable and thus the product will also be very less stable. So to overcome this, methyl group present on the primary carbocation shift downward. In the fourth step, thus there is a formation of tertiary carbocation which is more stable. And in the fifth step, this chlorine ion will attach to the cation present on the tertiary carbocation. Thus there is the formation of a stable compound 2-chloro-2-methyl-butane. Now let us do the second method of preparation, that is by the action of phosphorus halide. Let's see. In this there are further two different methods. First is by reacting alcohol with phosphorus trihalide. In this, chloroalkanes, bromoalkanes and iodoalkanes are prepared by this method. This general equation is given in the slide. For example, when ethanol reacts with the PCl3, it will form chloroethane. PBr3 and Pi3 are not stable compounds and are usually prepared freshly by the reaction of red phosphorus with bromine or iodine. And the second method is by reacting alcohol with phosphorus pentachloride. Chloroalkanes can alternately be prepared by reacting alcohol with phosphorus pentachloride. The journal reaction is given. Now let us take an example. Ethanol reacts with PCl5 to give the chloroethane. Now let's do the last method by using thionyl chloride. By reacting alcohol with thionyl chloride, chloroalkanes are prepared by using thionyl chloride SOCl2. Any alcohol group when reacts with SOCl2, it will give chloroalkane where SO2 and HCl gases release as byproduct and escape out, leaving behind the pure product. In this, the primary compound which is not possibly made in carbocation can be easily made, and in this tertiary can be directly converted into halogen. This is all about the preparation of haloalkanes. I hope you like this. Stay home, stay safe and stay healthy. Thanks very much.